So in this section, we'll be looking at circles, and we'll again be giving these same three representations: a visual and equation form and a set notation representation of a circle. In this case, I think drawing the visual one is pretty clearly the hardest for me. It'll do. So, what makes a circle deserve to be in this section on simple curves? A circle is one of the only shapes that we can actually give a concise mathematical description of. Take a second and think, what really is a circle? How can you describe a circle in a simple, intuitive statement? Not something you learned in algebra, but actually something that you could explain to a 6 or 7-year-old. A circle is the collection of points that are all the same distance from some particular special point. So in this case, my special point is our favorite special point, the origin. And the distance that I'm talking about is 1, 2, 3, 4 away. This shape that I've drawn here is the collection of points that are exactly 4 units away from the origin. So if I can just figure out how to write down the set of points that are exactly 4 units away from the origin, then I'll have a representation of a circle. Now, that language that I'm using suggests that I'm thinking of this third representation. I'm saying the set of points that are exactly 4 units away from the origin. Let's write that down. I'm going to leave some space here for our equation form and write this here. And let's see if we can translate this into notation that looks a little bit more like what we did with lines. I've written the set of points x, y, such that x, y is 4 units away from the origin. This is a perfectly valid description of the circle. This is a perfectly valid definition of a set. Sets do not always need to be written in completely formal jargon. It's perfectly fine in general to write down a set in more or less common English. So I should, to be a little bit more formal, I should at least specify that x and y are real numbers. So I have this description, and it's valid, but I'd like to clean it up a little bit. I'd like to be able to give a description of this that is slightly more mathematical than what we have here, or at least using slightly more mathematical language than what we have here. So do I have a way to express the idea that x, y is 4 units away from the origin? Well, we developed last chapter a method for describing the distance between 2 points given their coordinate representations. So given x, y, and 0, 0, I can write an expression for the distance between x, y, and 0, 0, which means that I can write an equation that expresses that that distance is equal to 4. So let's write that down and see what it looks like. Here I have written the expression for the distance from x, y to the origin. Remember that this is really just the Pythagorean theorem. This x minus 0 is the distance between x and 0. This y minus 0 is the distance between y and 0. And this expression just tells us the hypotenuse of the right triangle that naturally arises from looking at x, y, and 0, 0 in our coordinate system. And we're setting this equal to 4. So we have this description here, which is a perfectly valid equation representation of our circle. Normally, when we write the equation for the circle, we manipulate this a little bit to make it a little cleaner to look at. In particular, we square both sides of the equation. And we find x squared plus y squared equals 16. We should wonder, is squaring both sides of the equation something that's reasonable to do? How might it cause problems? Do we need to worry about this operation? So after squaring both sides, we now have our standard form for the equation for a circle. And we could replace this 16 with something slightly more general. This 16 was really 4 squared. We wrote this 4 because it was the radius. So I'll write here r squared. This right-hand side is really the radius squared.